Today we're going to talk about the Big Tree Tech SKR Pro version 1.2. Now I've done this basic tutorial before, but my users have explained that there are certain issues that they'd like addressed, one of which was the recent change while recording this of the Marlin firmware. Previous, Marlin had a way to select the default platform in platform.io.ini that is now changed, which causes a complexity to this tutorial that I'll resolve. So what I'm going to do is I'm going to explain the board by going around it like I did in my previous tutorial. So first of all, we have our steppers. We have our X stepper, our Y stepper, our Z stepper, our E0 stepper, E1 stepper, and E2 stepper. These are for your extruders, but they can also be used to create an additional Z axis or other axes if you so choose. Now, you can note that over here you have two jumpers. That's on your second Z stepper. Now, the thing you need to realize about that is if you're not using two NEMA steppers, then you can put the plugs on here to use just the one. Also, the jumpers over here allow you to set for different stepper types, such as the A4988 or DRV8825, which are step direction steppers. We also have various types of TMC steppers that you can use, such as SPI, which is Serial Peripheral Interface. And then we also have UART. So those types of steppers can give you the options of doing sensorless homing, so you don't need to use your actual homing. So what that means is that you'll no longer need to use the limiting switches for your X minimums or maximums, but these are also used for the detection of runout of filament for your steppers, being your E0, 1, or 2. Then they also integrated into this the ability to use backwards compatibility with older display types, such as the RepRap full discount display. So you have your EXP 1 and 2. I'm not sure where they are here, but you can see them silk screened on the board if you look closely. They also give you the ability to work with a TFT display, so that you can have a touchscreen capability or a backwards compatibility with that as well. Over here we have various types of pins. Some of these pins are used for, let's see, we have UART communication down here, and then we also have power pins, I believe, in here, and those will allow you to create 12 or 5 volts of power. It may go as high as 24 volts, but you'll have to measure those. But on the actual silk screen, it says 12 volts. There's also a 3.3 volt set of pins in there. Then we have these pins over here, which I can't exactly see very closely, but I believe these may be, well, we'll figure that out in just a second. I'm going to skip it for the moment, but I believe there's SPI pins, or serial peripheral interface pins. The new difference between the SKR Pro version 1.1 and 1.2 now with sensorless homing, or with the BL Touch, is that they've now added a 5th pin instead of 4, so that you have your extra ground. And then of course you have a set of auxiliary pins over here, which you can use for a second servo, but I've covered that in tutorials that will be in the playlist that I'll leave in the description of this video. Also, you have the way that you load your firmware right over here with an SD card. There's a reset button as well. Then there's a USB connection over here for serial peripheral interface, or not serial peripheral interface, for USB, which is Universal Serial Bus. And then there's a Wi-Fi connection over here where you can put a board to connect. There also is a connection over here for USB mail. I'm not sure what that's used for. Then over here we have a series of fan ports. Now if you haven't noticed, I'm marked red on one side and no marking on the other. That means that it's voltage. So you can set these up as either 12, 24, or 5 volt possibly, but don't quote me on the 5 volts. Then we have our extruder ports over here, which I've marked with red and no marking. That's for voltage and ground. But when you're using actual extruders, you don't really have to worry about voltage and ground unless you're using a relay of some type. So over here we have our actual power pins. So up here we have our stepper logic that you can connect to with your power supply. You also have your board logic right here. And like I said before, the red is for voltage. Then we have down here an actual connection for our heat bed, and then the power into our heat bed. So you can use separate power supplies, although I don't recommend that. Then down here you can also see that there's fuses that are car fuses. These are rather cheap to actually change. And then over here we have a jumper. This jumper is used for either direct power or 5 volts of power from your USB serial connection. So what I'm going to show you, there's actually one last thing I probably missed over here, and that's your thermistor connections. These are both for your bed and extruders to tell temperature. Now there may be other things that I did miss that I'll cover in other tutorials, but this is a basic video, so I'm just going to walk you through how to load the firmware now. But let's check to see which power we're on. And one of the tricks I use is my USB serial cable. If I plug it in right now, this means it's on USB power. If you're using TMC type steppers, you're going to have to take the power and place it on the other 2 pins. And now when you plug it in, you won't have power unless it's through your PSU or power supply. But in this case, we're going to put it on USB power to load the firmware. So I'm going to move that back over. So the process for loading firmware is kind of simple. You open up one of your converters like I have for my SD card. You pull out the actual SD card and then you place it in here. Then you'll place this inside your computer. You may hear a beep when you plug it into your USB. And what we're going to do is we're actually going to go over to VScode in just a second. But I want to show you what it looks like for one of the board diagrams or several of them. So I'm going to start with the actual display right here. This is for a version 1.1, but it shows most of the functionality around the board. Obviously you can see there's a 5th pin that's been added for the version 2. You have your extension pins, but let's see how the logic works for those. So if I go over here, you can see a pinout diagram. This is actually for the SKR2, which is incorrect. So I'm going to go back over to the Big Tree site and show you how to find it. So if you click on the Pro, and then you click on the Pro here, you'll be able to find, hopefully, pins for it in one of these folders. Now, obviously, I'm not going directly to it, so I have to look through here and see if I can find it. So unfortunately, I'm not finding it right away. So let's see if it's in the manual. So here we go. So it looks like I'm in the wrong section over here. So I'm going to click back and go back over here and see if it's actually in here like it said before, which it is. And I'm going to scroll in here so you can see it a little bit better. And I'm going to zoom in. Now this might get a little weird because apparently I can't zoom in too far. But you can see the actual pinout numbers when you see PF2, PE9, and PF1. These will correspond to our actual configuration inside VScode. So if I were to open up a Marlin firmware that I've downloaded and extracted in my downloads folder, you can see over here that when I open it up, first I have to go to the first Marlin, then the second folder, and then select folder. That's usually what happens when I extract it. You'll see that there's actually, first of all, the platform IO type that I'm going to actually address now from my previous video. This folder originally didn't exist, so they've broken these out in a folder by actual board type right here. So they're each separate INIs, whereas it used to be one INI. So the one that we're actually looking for in this case is STM32F. And if we were to search in here for our board being SKR Pro, we'll find it right here and can just copy it. Now that might not make a lot of sense initially, but I'll show you why and how you can look that up if you're not sure for another type of board. So in this case, I'm going to minimize the INI folder. I'm going to go over the Marlin folder, then the source folder, then the core folder, and then boards.h. In here, I'm going to search on SKR Pro. And as you can see, the profile right here for our board version is right here. So I'm going to copy that so that we can actually set this up in Marlin for a basic firmware load. So I'm going to go to the Marlin config for a second. I'm going to search on motherboard. I'm going to paste that right here over the ramps. Then I'm going to scroll up and change the serial port to -1. And that'll allow us to actually load firmware via the USB serial port and maintain our connection so that we can connect via USB. Now these may vary because the new version of the Marlin firmware gives you the ability now to actually use obviously a second serial port and a third serial port. You can also set the actual baud rate for each of the serial ports. So this might be useful if you're using a display where you want to change the baud rate to 1500 or 115,200, pardon me. And that'll allow you to set it up. Now I've covered a lot of tutorials on how to set things up in the board, which will be in the description. But first I want to show you this last piece that's kind of important. If you go to source, pins, and then you find the board type, which is STM32. So we have to look in here for the folder. So there's STM32F, then there's F4. This will show you what your pins are. So in this case, if we go to the Big Tree Tech SKR Pro version 1.2, you'll see that it refers to a common set of pins. That means include this in our set of pins. So we have to go up and look for it. So right here is the SKR Pro. These are actually the pinouts for your board. So each of these pins is a signal pin that it's making reference to that it uses. So that's what makes it common to this board, or the multiple boards in this case, because this one's still the same. So what I'm going to do now is show you actually how to build the firmware. Now all we have to do for this is actually go over to first the garbage can. We want to do a clean, and the reason that we do that is because in the .pio folder, when they build it before they release it, they leave something left behind, being the Mega 2560. So to get that out of there, you just click on the clean, and that'll get rid of that board type. Next, what we're going to do is click on the checkbox for build. Now this does multiple compiles. Right now it's downloading what it needs to compile, and now it's compiling. While that's occurring, you can see in the .pio folder, it's starting to populate. If you run across an error where it fails to compile, where you see something red instead of yellow, that means that you're probably going to have to hit build a second time, because sometimes things build out of order. If it fails on the second time, then go to the very first red error that you see and rebuild. And by the way, the yellow ones are generally warnings, so you can ignore those unless something doesn't work. So to load the actual firmware now, what we're going to have to do is go to the .pio folder, find the actual firmware.bin, right click, and then go to Reveal in File Explorer. Inside here, we have the firmware binary file that we want to work with. So to load that, we're going to copy it over to this folder. That's the SD drive that we're going to plug in to the SKR Pro version 1.2. But after it loads, it gets renamed to capital letters firmware.cur. That's so it does not reload every time you load the board or power it on. It does say cursor type, but in this case, it's considered cur, being current. So I needed to point that out because if you ever want to reload this, you'll rename it to the lowercase firmware.bin. So I'm going to go back over here, right click, and I'm going to say send to the USB drive. So now that it's on the drive, we can actually go back over to the workbench for a moment, pop out the drive, connect it over here, and then connect the USB to load the firmware. So once that's complete, we can actually test this now in Pronterface. So if I go over to Pronterface, the first issue that I currently have though is that in Pronterface it says COM port 1. So technically I know that's not going to be the COM port for the board. So I'll show you how to resolve this real quick. So on the desktop you're going to type device manager, and then when that comes up, what you're going to do is you're going to go to your ports and expand it and see how it says 13. We know 1 is default to the desktop computer, but 13 is the board that we have connected. So I'm going to close this. I'm going to go over to here and see if it's in the list, which it is not. So I'm going to click on here and type 3 to make it 13. Now I'm going to try and connect. So as you can see, the printer does say connecting. Printer is now online. So one of the things I like to do is test end stops for the board. And the reason that I do this is to make sure that I'm connected. But currently there are no end stops connected, so they're probably all going to come up triggered. So let's try the command. It's M119 and we'll press enter. So as you can see, the X minimum, Y minimum, and Z minimum do say triggered because nothing is connected. So if you like my tutorial, please press the like button and subscribe. And thank you for your time. And for those that do want to see tutorials before they come out, I do post them early on Patreon so that you can see what they are. So if you're interested, that will be in the link in the description.